Hello all, welcome to my YouTube channel. Today we shall do hypothesis testing for mean or means using one sample t-test, independent sample t-test and pair t-test using SPSS. Let us start with one sample t-test. Okay, so one sample t-test has some assumptions. Okay, what are these? The first assumption is that the test variable must be continuous. Let us go to variable view and see. In SPSS, the continuous variable, that is interval or ratio variable, are given the measure scale. Okay, so we can see that the variables age, pre-test, post-test and stress follow-up has the measure scale. Okay, so we can use these variables for our t-test. Okay, and the second assumption is that the observations are independent of one another. The data is collected in such a way that the observations are independent of one another. The third assumption is that the dependent variable should be, or the test variable should be, approximately normally distributed. You can use SPSS normality test to find out whether the test variable normally distributed. And the fourth assumption is that the test variable should not contain any outliers. We can use box and whisker plot to find out if there are any outliers. Okay, so I have explained this normality and box and whisker plot in my earlier videos. So for our convenience, we assume that the variable is normally distributed and there are no outliers. Suppose our test variable here is age. Okay, so we start with one sample t-test. So one sample t-test is test for single mean. So for that we need a null hypothesis. Okay, so let us assume that the null hypothesis is that mean age is equal to 20 years. That is, mean age of these patients is equal to 20 years. Okay, so we go to analyze. Then compare means and proportions, one sample t-test. Let me reset. Okay, so our test variable is age and hypothetical value is the test value. So whatever we define in the null hypothesis, test value is equal to 20. Okay, then you can go to options. Confidence interval percentage is 95%, that is level of significance is 5%. You can keep it that, and or you can change if you want to. Okay, and if you want effect size, you can check the box. If you do not want effect size, you can remove the tick. Okay, so that's okay. So this is our output. So first box is one sample statistic, that is sample size, mean, standard deviation, standard error are given. Then the test value, one sample t-test. Okay, so the value of test statistic is t equal to minus 10.254. This is the value of the test statistic. Degrees of freedom for one sample t-test, we know that degrees of freedom is n minus 1. So that is 50 minus 149. And both one-sided and two-sided p-value are given. Okay, so if your alternative hypothesis is that mu not equal to 20, then you select the two-sided p-value. If your alternative hypothesis was that mu less than 20, then your one-sided select the one-sided p-value. Okay, so we can see that the p-value is very less. It is less than 0.05. Okay, so we reject the null hypothesis. Though it is very less, it is less than, actually the p-value is less than 0.001. Since our level of significance is 0.05, so we are comparing with level of significance. So p-value is less than 0.05, so we reject the null hypothesis. So we conclude that the mean age is not 20 if it is two-tailed test. If it is one-tailed test, then we conclude that mean age is less than 20. Now we shall do two sample t-test. Okay, for two sample t-test is a test for two means. Okay, so we compare between two means using two sample t-test. Okay, suppose our test variable here is age, okay, and we want to see whether the mean age is equal or different among the two genders, male and female. Okay, so there are two variables here. One is dependent variable, another is independent variable. What is the independent variable? The gender or sex, male and female. Okay, and what is the dependent variable here? It is the age. Age is dependent on whether the person is male or female. Okay, there are few assumptions for two sample t-test. First assumption is that the dependent variable should be measured on continuous scale, that is either interval or ratio. So in SPSS we know that this should be the measure scale. Okay, and the independent variable can be nominal or ordinal. So the independent variable can be this one, sex or group. Okay, the assumption 2 is that the observation should be independent of each other and there should not be any outliers, and the dependent variable must be normally distributed. Okay, so we start in independent sample t-test. We go to analyze. Okay, compare means and proportion, independent sample t-test. Okay, here test variable is what? Age, and grouping variable, that is the independent variable on which the age is divided into two groups, male and female. Okay, so this is sex here. Define groups. Okay, so before defining group, let us go to variable view and see that the sex, male and female, are given the value 1 and 2. Okay, so male for 1 and female for 2. So first group 1, second group 2. Okay, then we go to t-test. So define groups. Group 1 is 1, that is male, and group 2 is 2, that is female. Continue, and then in options you select the level of significance. It is 5%, so we continue it like this. Okay, so this is the test result for independent sample t-test. First is group statistic for male and female, sample size, mean, standard deviation, standard error given. Then independent sample t-test. Okay, so independent sample t-test is done in two ways. First method is that we assume that the population variances are equal for two samples. So equal variance assumed, and second one is that equal variances not assumed, when population variances are not equal. Okay, so which test result to take? So when equal variances are assumed, before that F test is done. You know that F test is done for testing equality of two variances. Okay, and the value of F statistic is 0.005. Okay, and significance, that is p value, is 0.946. that is very high p value. That means we fail to reject the null hypothesis that the population variances are equal. So we conclude that population variances are equal. Okay, so as population variances are equal, we will take the first row as our test result, that is equal variances assumed. So value of test statistic t equal to 0.112, degrees of freedom 48, that is n1 plus n2 minus 2, 25 plus 25 minus 2, 48, and one sided p value and two sided p value both are given. Okay, so if your null hypothesis is mu1 not equal to mu2, that is mean of male is not equal to mean of female, then you take the two sided p value. If your test statistic is, or if your alternative hypothesis is mu1 less than mu2 or mu1 greater than mu2, that is one tail test, then you take one sided p value. Okay, and the p-value is very large for both sided, so we fail to reject the null hypothesis. That means we conclude that mean age for males and females are not unequal. Okay. Now, if the equal variance assumed, a value of f test statistic was very large and p-value, the value of p-value is very small, then we reject the null hypothesis that population variances are equal. So, we should take the second test value, that is equal variances not assumed. Okay, for in that case our value of test statistic is 0.112 and degrees of freedom 47.720. Okay, now we go to pair t-test. Pair t-test is done when for same set of sample we have two observations. Okay, for example, for we have the same set of patients, 50 patients, we have two observations. One is pre-test value, another is post-test value. Okay, so the pre-test and post-test are paired value. For example, ID number 1, okay, the pre-test value is 36 and post-test value is 53. So this is paired observation for this first sample point. Okay, so in that case we do paired sample t-test to compare mean between whether mean pre-test and mean post-test are equal or not. We use pair t-test. Okay, so for pair t-test we go to analyze, okay, and then compare means and proportion, paired sample t-test. Let us retest, reset this, and pair 1, there will be two variables, variable 1 and variable 2. So for pair 1, variable 1 suppose pre-test and variable 2 suppose post-test. Okay, and then again the level of significance. Okay, so this is the output viewer window, and here you can see paired sample t-test. Okay, and this is the value of the test statistic t equal to minus 5.240, degrees of freedom 49, and for one-sided p-value is less than 0.001, two-sided p-value is less than 0.001 again. Okay, so there is high significance. So we reject the null hypothesis that the mean pre-test is equal to mean post-test. We reject this null hypothesis. Okay, and we conclude that there is sufficient evidence to conclude that the mean pre-test and mean post-test are not equal. So this is how we conduct t-test using SPSS. Okay, next, in the next video I shall upload how to do ANOVA, that is ANOVA F test using SPSS. If you like my channel, please like and subscribe. Thank you for watching.